In this video, I will continue my discussion about advanced queries, how we define alias tables, why we need them. To consider this question, items listed for more than the average sale price of all items in their category. Let's say TVs, within the TVs, all TVs that are listed for more than the average sale price of TVs and other categories. For each category, we need a list of items for more than average sale price. We need two tables. We need item table for category and list price, and then we need sale item, sale records for the sale price. The relationship between these two tables, stock keeping unit as primary key in item and foreign key in sale item, we can have a list. Well, the problem here is that when we are running the query, category from item table must match records from the same field. That means category of individual items must match the category of calculated average sale price. It's not possible to reference the same field twice from the same table, so we define an alias table. An alias table is the same table given a different name. The syntax is table name as, well, a different name. For example, item table as item 1. We can create as many alias names for a table as we need to. For this query, we start a simple query. Select the item SKU, brand, category, and list price from item table, just one table, where the list price is greater than a number. And that number is returned through a subquery, which is calculating average sale price, is average of sale price given a name, from item as item 1. So here we are using the alias. The key point is the last line of the nested query, where item 1 category equals item category. Item is the name of the table in the main query. Item 1 is the alias for the same table in nested query, and we can use alias table to make it possible. Now the next question. Well, this next question is a little more difficult to answer. Items sold for more than the average sale price of their category. Here we need to do two joins. For the main query, we can use keyword distinct to prevent repeating results and selecting the primary key of the item, brand, category, sale price from both tables, item and sale item, they both required. For sale item, sale price is greater than the price that is being returned by the subquery. That subquery uses the alias for item. Call that item 1, join sale item on equal stock keeping units. Here are primary and foreign key. And the last line, categories from both tables, the table and its alias, will match. If you run this query in MySQL, it times out, returns an error after a while, about 30 seconds. It takes roughly hundreds of times more to run this query comparing to the previous query. If you use Access, you have to wait several minutes. But with the existing database, you may get the result. How we can get away with long running times? There are two ways in MySQL to do this. Running this short query, set global, while changing the global value of maximum execution time, max execution time. Please note the underscores. This is a defined variable. Let's say, for example, set it equal to 500,000. This value is defined in milliseconds. So 500,000 means 500 seconds. And this is a definition for all queries. Or do a local setup. Within the query, right after select, and use the common syntax / and asterisk open and then close it with asterisk / plus max execution time. Use a pair of parentheses and put the number there. Again, if you put 500,000, it will be 500 seconds. And then continue with the query. These setups work with highest level select query only. That means a simple select query. If you have a nested query, then it's not going to work. So what to do? There's always a more efficient way when we have a trouble running A query takes a long time to run. We can run a query and save it, a saved query, or as we call this, a view. We can save it as a name, category average view. It should be one string. And this is the syntax. In fact, the first line is created in MySQL and many database management systems. So the body of the query is just as any other query. Selecting category and average price of category from the tables, item and sale item, group them because we have an aggregate function, and then save this. We will reference this view in our main query. And here is the main query. We can return the primary key, stock keeping unit, and the value we saved along with the category. So category average view is the saved view. It works just like a table. Category from this view, and then sale price. From the join of that average view, category average view, with the two tables, sale item and item. Under criteria, sale item sale price is greater than the average sale price saved in the view. And since we have multiple averages, one for each category, the category average view, its category must match the item category. In some cases, we want to look up values and assign values. Assign new values, numbers, or strings in a results table to values of one of the existing fields. Case function can be used. For example, here, a simple example. Assign small to 32-inch TVs, medium to 40, and large to 50 and larger. We can start the query, a select query, return the primary key, brand, list price, and then start the case function. Keyword case, and then for each assignment, when, then the value, field name, that's the name of the field in the table, screen equals 32, then, that's the keyword for case function. Here we can use another function, screen, comma, small. Well, the answer that is returned is the entire string. Small and screen, which is the field name, will return the value. So for example, for every 32-inch TV, the result will be 32, then there will be a space before small and followed by small. Same thing for 40-inch TVs. We'll have a 40 in result, one space, and then medium. For 50-inch and larger, here we have a screen greater than or equal to 50. We'll have the screen size 50 or 60, as we have in database, then one space and large. There's an optional keyword else. If there's a value that's not matching to any of these, we can return a value for that too. Here, for example, return unexpected. As any value, any string, a non-numeric value that we use in a formula, here we have to enclose them in singular or double quotes. We have to finish case function with and. And then one more optional keyword, as, give it a name. If we don't use as size, then the entire case statement will be the name of the field. That's something we don't need to see. And then the results will return from two tables, item and TV. In a second example case, we can do calculations and even use logical statements in case function. In this case, we're going to look at delivery time of suppliers, which is the difference of receive date and order date. We'll look at all records and then use the case function. So we start with the difference of receive date, order date. If it's less than equal to 10, then return agile. If that's less than equal to 20 days, then early. Less than equal to 30 days, then normal. Less than equal to 45, then late. If in one case delivery is less than 20, it might be less than 10 as well. Is there any mix-up? No, because we sorted these numbers. We start from 10, 20, 30, 45, and then last line more than 45. If there is any case that is less than 10, we got that here in the first line, and the query processor goes to the next record. It's not going to pass to less than or equal to 20. We can even have logical statements. For example, here in the last one, we don't need to, but we can use this. The difference of receive and order date greater than 45 and the same difference less than 100. We can use and or and combine statements in case function. We can use optional else and then and as delivery status. That's the name we assign to the case field. If you're access user for a similar performance, you need to use a switch. So we start the query, select statement, all those fields we need, the difference of receive date and order date as delivery, and then we start with switch. Then the entire function is within a pair of parentheses. Open the parentheses, receive date minus order date less than equal to 10, then agile. We don't use the keyword then. There's just a comma and space in between. And then put down a comma, go to the next line. Less than equal to 20, 30, 45, and even the logical statement greater than 45 and less than 100. We can use exactly the same thing here and return extreme date. We can close the parentheses. We don't need the AND keyword we use in MySQL. And then from. Join of the tables. If you're going to return a value based on the value of another field, we can use if function too. The syntax is quite similar to what you might have used in Excel. 3 arguments are there. There's a logical test with the results of true or false. And then second argument is a value if the result of that logical test is true. Third argument will return if the result of the logical test is false. In this case, we can use the saved view, inventory view, and item table. You select query to return backordered if the inventory value is negative, and just return inventory if the value is positive. So if we oversold an item, we'll see a backordered in front of the inventory record. Here we need to use an if function. If inventory less than or equal to 0, return backordered, otherwise inventory. Union queries are used for combining lists from 2 schemas. Of course, we can use them to combine values from the same schema, same database, but when we're going to combine values from 2 schemas, it's very handy. Here, for example, I'm going to use 2 schemas you already have. One of them is ECD, and the other one is Sequila schema that comes with MySQL. We're going to put first name and last name of customers from ECD and actors from Sequila together, and in front of each record, we want to indicate it's from ECD or from Sequila. So we start one select statement. Customer first name, we'll call that column first. Customer last name as last, so we'll call that column last. Then just ECD, this is the third field, a fixed value, and we will give a name to that, company. From ECD.customer, just like field name and table, here we can call schema name dot table. This is one list, and we'll continue that with another list with exactly the same 3 columns. Keyword union between 2 queries. Select actor dot first name. Well, this is the name of the field. As we see, first underscore name is the name of the field in actor table in Sequila schema. Actor dot last name, and then the third field that will return just Sequila. From the schema name, table name, Sequila.actor. Giving the same names in the second query to the fields that we're returning is optional. If you don't give them a name, they just go into the fields we already prepared for the first query in the same order. So you will run this query and you will get a list that combines first name, last name from 2 schemas, and then in front of each record we'll have one field that determines if it's from ECD or from Sakila. And for data definition commands, we have a link here for a complete list of data definition commands. I mentioned a few of them here. Create schema table, or creating columns and assigning their data types. Popular data types we use in tables are listed here: primary key, constraint, alter table, drop table, etc. And here are a few examples. When creating a new schema, create schema if not exists. So this will prevent the system to try to create a schema that already exists, followed by a schema name, and then mention the default character set, which is usually UTF-8. That's Unicode transform format, and 8-bit blocks are used for defining characters. For creating a table, for example in ECD schema, this is a list. Create table, keyword for creating table followed by the table name, and then within a pair of parentheses we can include field names and their data type, size if necessary, and then define the status. Should be null, not null if it has a default value, or being null by default if a field should be a primary key. If there is a foreign key, we'll make it a constraint. Here we have keyword constraint. It should be a unique name for a foreign key. If you create a duplicate constraint, then there will be an error in the system, even if that constraint is defined for another table. And then after the name foreign key keyword, the field name in another table references item, in this case the table name and the field name, and what to do and delete and update. And delete, for example, here no action on update, cascade, could be cascade on both. For data manipulation, for example, inserting data into tables. What we need to do when inserting new data is locking tables. So we can start with lock tables, the table name, and followed by write. This is the end of this first line query, and then followed by insert into table name, values. Then we'll follow with the data items fields in the same order that we have in a table. Just mention the values separated by commas, enclosed every record enclosed in a pair of parentheses, separated from the other records by a comma, and we have a list of all those records we want to enter. At the end, semicolon, like the end of a query. After finishing the data write, then unlock tables. Sample of deleting. If you want to delete a record, the keyword delete, we start the query with delete. Delete from computer, for example, where, well, we can determine the criterion. For example, one of the computers will not be in inventory anymore. SKU, this is a primary key, like we'll pass the primary key of that computer, and then the records of that computer will be deleted. Or updating, changing the data, existing data in a database, update followed by the table name, set, that's a keyword set, field name equals a value. That's the new value that will be entered in that field, where the criterion, the SKU like followed by the primary key of the records. All the screen fields of records with this primary key will change to 21.